All right, question number 2 asks you to calculate the chemical potential for sodium across a membrane, given the following information. All right, now for a chemical potential of anything that is charged across the cell membrane, you'll use this particular equation here. So the chemical potential is the same as delta G. All right, now if we're talking about something that wasn't charged, we could use this exact same equation. We would just lose the part there dealing with the charged species, or the charge. All right, so we want to use this particular equation. We're given R, or we know R, the temperature, we could assume standard temperature. We're given the concentrations of the ions inside and outside the membrane. The charge on sodium is something we know about, is +1. Oops. So Z we know is +1. Faraday's is a constant, so we can look that up. The only thing we don't know is delta psi. All right, this is the electrical potential of the membrane. All right, this we actually have to calculate then using the rest of the information in this table. All right, so in order to do this, we're going to now jump down to here. This is the equation that allows us to calculate the electrical potential across the cell membrane. All right, R, T, and F, we already know what those are. The P values here are the permeability coefficients. So those are these values up here, and you'll be plugging them in to the equation down below as appropriate. The C's in brackets, these are the concentrations of the cations, either inside this cell, right, these concentrations up here, or outside the cell in the blood. All right. The A's in brackets, right, those are the concentrations of the anions. So the anion concentrations, we only have one anion to be concerned with here, the chloride. All right, and so we'd include that, its concentration either inside or outside the cell there. Rita, you need to be quiet. All right. Now, basically, we can plug all those values into this equation. All right. I'm doing this down below for you here. I just went ahead and converted all the millimolar concentrations to molar. You don't necessarily have to do that in this case, but anytime you're dealing with equilibrium, which is what we're dealing with here, it's always a good idea to just go ahead and convert them to molar. All right, and basically then we end up with an electrical potential of -83.2 millivolts. All right, so we could take that value and plug it into here. So now we have everything we need to solve our delta G equation. And we can go through it, and we'll get a delta G for sodium moving across this membrane of -14,200 joules per mole. All right. Now, the second part of the question asks us to calculate the free energy needed for phosphate to cross the membrane if the inside concentration is 5 millimolar and outside is 50 millimolar. All right. Assume that the charge on the phosphate is -2. All right, so we're again going to use this exact same equation. All right, so the delta G, the energy needed to cross the membrane, is the same thing as the chemical potential across the membrane. All right, so here we've already determined the value for delta psi, so we already have that. The only thing that is different here are the concentrations of the phosphate across the membrane and our value for Z, right? Because the charge of phosphate is -2. So we plug that in there, and we can solve this whole equation, and we get a value of 10,350 joules per mole.